Hi everyone and welcome to a new podcast powered by Turbine. In this new episode, we're going to have a tutorial on how to use Mollusk to test our Solana programs. So stay focused and let's build. Before we dive into the actual tests, I would like to give you a small intro about what Mollusk is. So the best place is the GitHub page, and as per ANSA, Mollusk is a lightweight test harness for Solana program. The reason it is a lightweight is just because it creates a minified instance of Agave's program cache, transaction context, and invoke context. And it uses these components to directly execute the provided programmer's elf using the BPF loader. The thing is, it does not use the accounts database or bank. And because of that, when you're setting up your tests, you're going to have to provide the let's call it the context of your accounts before you send your transactions to be tested to process your instructions basically. So just a quick walkthrough for you to understand how it works. So you can see here that they are setting up their keys, and then they are setting up their instruction where they define those accounts, and then they define again those accounts they're going to be passed in the transaction. So the mechanism is going to be always the same. You get the keys, you set your instruction parameters that will have your program ID, will have some data, and then you pass your account metas, and that is what is used to build your instruction. And then you build your transactions accounts, and then when you process the instruction, you pass your instruction and your accounts. That's it. Now let's see this in practice. All right, let's go to an actual project. Before we write our tests, let me show you what I've prepared for you. So I have two projects here. This Anchor Vault, it's the same one that I use on the previous episode when comparing Anchor with Pinocchio. And but we're going to write those tests. And then afterwards, we're going to write one test for the escrow so that to show you a different example. So before we write our tests, we need to understand what's going on with our vault. So our vault, it's a simple deposit and withdraw of SOL into a vault. It has this instruction that is called deposit, and this instruction called withdraw. And this is our accounts. We have a user, a state, a vault, and a system program. And the withdraw has also a user, a state, a vault, and a system program. But they have different constraints, basically. And one is initialized, and the other it isn't. For example, for the state here is initialized, and for withdraw it isn't. And why this is important? Because we need to define our accounts when we start making our tests. Because as I said earlier, Mollusk doesn't have any connection to the database, so you have to set that for your tests. But let's first try to determine what we really need when writing tests in Mollusk. So we're going to need the pub keys for all the accounts. We're going to need to get a Mollusk instance. I almost forgot about that. And we're going to need build the accounts. We're going to need to get the account or build the account metas to pass to our instructions. We're going to need to have get our data to pass to our instruction. Then we're going to build our instruction. We're going to get the accounts, the transaction accounts. And finally, we're going to process our instruction. Process and validate in our case. Okay, so this could actually be this first thing. It just doesn't matter. So we have our pub keys or Mollusk instance. We're going to build our accounts. If any of these accounts have any data, we're going to have to inject that data. So inject data to the accounts. Then we get the accounts meta and the data from that instruction, so we can build this instruction. And after that, accounts, so we can process and validate our instruction that's going to get our transaction accounts and then our instruction. Okay, this is the usual structure. Okay, this will make more sense as we start testing. So let's try to see what do we need to start. First, we're gonna need our program ID. So what we can do is define a const here. Const, let's call it ID, which has which is a pub key, and let's use Solana SDK for this. And this pub key, you're gonna obtain it by getting the pub key, and like this. And what is our pub key? Let it get it from our librs. Yep, it's this one. And let me check. Okay. Let me save this because usually this is not recognized. Okay, so far so good. Now, yeah, what happens is for some reason it doesn't recognize it. So what I do a lot of times is I just do something like this. Makes sense. Pub key and then pub key. Cool. Now, what doesn't make sense here? Something's wrong. Yep. Okay, so what else do we need? Let's check our deposit. What pub keys are you gonna need? We're gonna need user pub key, and we're gonna need a state, a vault, and a system program. Okay, let's create a const for user so we can use in both tests. So let me see. Const user is also gonna be a pub key, and let's do something different this time. Let's do pub key new. We could be new or unique. Let's just to be different. New from array, and then we create our own array, which is gonna be, let's say, OX01, a length of 32 bytes. Yep, perfect. Instead of being random, I'm just creating one with the exact same number and same bytes. So we already have our program ID, our user ID. Now, let's get our Mollusk instance first. This is the first thing I actually like to do. So let's see. Let's create our Mollusk, which is no, it's not like this. It's Mollusk equal Mollusk, and we need to import this, and then we do new. Okay, and he's gonna ask us for the program ID and the program name. The program ID is a reference to this ID that we just created, like the pub key. And the program name is actually a string where the file is located. So since our tests are in the same folder, where are our tests? SRC? No, in the same level as Vault. And our what we need, our program is actually on our target here. That's our binary. So what we're gonna need is to go up, go to target, and then deploy, and the name of the file is Vault SO. So the SO is not needed. You recognize the file type. Okay. So every time we initiate an instance of Mollusk, we need to do Mollusk new, pass the program ID, and get the binary. So for this, you're gonna need to deploy deploy your program. Not deploy, I'm sorry, build your program so you can get it to binary. And that's what I did before we start. I did the anchor build to get this binary. Cool. We already have our Mollusk instance. So now let's get the rest of the keys that we need. So the other keys we need are the state, let me check, deposit. Yeah. All we need is the state and the vault, and they're both PDAs. So since they're both PDAs, we're gonna need to use find program address. So let's call it state PDA and then state bump. Let's get them from pub key find program address, and we're gonna need the seeds and we're gonna need the ID. So what are the seeds for this one? We can just copy this. Our seeds are these ones, okay, but actually need a reference to that. The thing is, we don't have the user key. Our user was already determined by the const, which is user. And the program ID, this will be our reference to our ID. Cool. So this way, we're gonna have our state keys. Let's do the same for the vault. So let's call vault bump, and let's go to the deposit, and let's get these keys, the seeds, not keys. And we do this, but this time we're gonna use the state PDA, which is our pub key. Cool. So again, what we did was making our const a program ID, your user pub key. We initiated an instance of Mollusks. We did our state PDA. We obtained it from find program address, and then we found our vault PDA. All right, first step is done. So what do we need to do now? Now we need to go to our get our accounts. Okay, so let's user account equal, and now we need to get the account from Solana SDK. Then you do new, and we need to pass the Lamperts, the space, and the owner. In this case, it is a user account. I'm gonna give him 1 sol, so 1 Lamperts per sol. The space is 0 because there is no data in here, and the owner will be the system program since this is a system account. So, oh, this reminds me, we need the system program, right? Because of here, and because we need it here as the owner. Let's get that. Let's get the system program account. So the system program is given by the Mollusk, by a method they have. So we just do system program, system account, okay, and this is equal. And now let's use the program. I'm not sure which one is it. Program. I think it's from Mollusk, not from here. Let me think a little bit better. Yeah, it is for Mollusk SVM. This is not correct. Let me delete this. I don't need this one. I'm sure it's from here. So let's like this program, and now this will work. This will program, and this program is going to be keyed account for a system program. Cool. And this will give us the system program pub key and count. And so now we can pass a reference to the system program. Cool. And why is complaining? Let me check here. Oh, because I'm still on the space. Space 0. And what about now? Yeah, it went away. So we built our first user account, and we're gonna need an account for all of them, except for the system program, because when you use this method, it already gives us a system account from our system program. So we have our user, we're gonna need our state PDA and our vault PDA. So let's see, state account is gonna be account new, and this will be initialized, so we'll have 0 lamparts, 0 space, and the owner at the time will be system program. Okay, so why is this? So when we pass these instructions to our these accounts to our instruction, it has to be the state. They have to be in a state that they are at the time of the instruction, and at the time this hasn't been initialized. So this is just an address. That's it. There's no space. That's going to be allocated by anchor and this instruction, and there is nothing in there. There's no lamparts, nothing. So that's what we're doing here. And the same is going to be for the vault. Okay. So let's change this to vault. Cool. All right. So far so good. We built our got our Mollusk instance. We got all our pub keys. We got all our accounts. Since the accounts are only being initialized now, there is no data to be injected in this instruction. What we need now is to build our instruction accounts meta. So let's call it instruction accounts. Let instruction accounts, just this, equal. Now we're gonna need to make a vec for this. So let's vec. Cool. And this is very easy. You just need to do account meta. Account meta, and you're gonna use the SDK version, and then new. So when we do new, it automatically assumes this is a writable account, as you can see here. So you just need to define if this is a signer or not, and what pub key you're referring to. In this case, will be our user. Then we're gonna do account meta new for our state PDA, which is a signer. No. As you can see here in this instruction, the only signer we have here is we're initializing, and then the CPI transfer is done by the user, which is the only signer you can also see here in our accounts. Okay, so let's do the same for our vault. And lastly, we also gonna need to pass our system program. And this case is gonna be new with read only. And this is gonna be a system program. And this is false as well. Okay, we got our instruction accounts. All good. So, as we defined in the beginning, we have our instance. This is so annoying. What I could do is, to avoid this, let's do it like this, and this could be pub key. Yep. Okay. Will it go away? should go away. Yeah. Cool. But this will gonna make me do this every time. Perfect. Okay, and this I forgot to say, this is true. Our instruction data. How do we obtain this? Okay, so first, what is the instruction data if there is any? We go to our librs and let's check. Yes, so our instruction is expecting an amount. So let's define that amount. We do, let's call it let transfer amount, and let's say that's a U64. Let's say we want to transfer 5 sol. No, we need 0.5 multiplied by lamperts per sol. Let's just transfer that amount. Okay, and now we just, what we're gonna need. So we now have this as our data, but we need to pass the data in a way that our instruction is gonna be able to read. So we're gonna need to serialize our data. So to do that, we're gonna use anchor, because anchor uses a discriminator, and we're gonna have to pass that discriminator to our instruction data as well. So for that, we're just gonna do volt, and then in our volt, we're gonna get our instruction. Now, instruction and not instructions. This is something that Anchor provides us to get the deposit struct. Okay, and in this struct, since if you didn't have any data, we would have this as empty. But since we need to pass, we want to pass this argument, we're gonna do transfer amount, and then we end up by doing dot data. Okay, this is how we do it. Volt instruction deposit, and then we pass our arguments. Okay, let me see what's wrong with this. Yeah, because yeah, makes sense. Makes sense. Let's do then like this. Yeah, makes sense. Now, actually, since this is 500,000, no, I think this is make more sense. Okay, so he's gonna complain about okay, why can't find this data, this instruction here, and send data is not there, because we're gonna need the anchor lang instruction. So we come here and we do anchor, well, use anchor lang, and then we do instruction data, and this is how we get this. And this should be okay now. Let's wait to I just saved. Yep, cool, went away. Okay, so we have our data. Okay, so every time you use an anchor, you're gonna have to do it this way. You're gonna have to call the anchor instruction data, where you can get the struct, and this struct is for each instruction function that you have here on librs. Okay, so if it is deposit, it's gonna be capital deposit, and then all the arguments you pass. So if it was, for example, Pinocchio, it depends. You just have the serialized data, and you have to serialize the data on your own. And I don't know how they pass it depends on your own program how you pass all the data and how you serialize, and you're expecting it here. Anchor does this. Okay, this is like anchor serialize in the background. All right, what we have so far, we have what we've done. We have our instance, we got our pub keys, we created our accounts, and then we created our account metas. So it's about time we use, and the data, of course. So now we can use what we have to build our instruction. So let's call instruction, and then this instruction, the way we build it is we're gonna call the instruction argument from struct, and then we gonna call the method called new with bytes, new with bytes. And here it is expecting a program ID, which we defined it is our ID. The data we just passed, so it's the same. And the accounts are the accounts meta. So it's the instruction accounts. Cool. And this is a reference? Yeah, it is a reference. Cool. All done. So far, so good. Now let's go to our transaction accounts. Let tx accounts. And this is going to be equal, it's going to be a new vec. So, but it's going to be a borrowed vec. Let me see, a reference. And this time, the transaction accounts have to have your pub key. So let's start with the user. So it's a user. And then we need to get our user account, which is going to be cloned. And then we do the same for the rest of the accounts. So state PDA, state account, dot clone. And we go for the vault PDA, vault account. Oh, no. Messing things up. Vault account, dot clone. And if you don't clone, it's complaining about moving, by the way. So you really have to do this. System program, system account, dot clone. Cool. And it doesn't need a reference here because this is already a reference. Is it? Yeah. Okay, so we built our instruction. We build our transaction accounts, which are has the pub key and our account. Please take in consideration that both account metas and our vec of accounts need to have the same order that you have in our instruction. So in our case, user first, states second, vault third, and system program fourth. Okay. All is done. Our tests are prepared and ready for us to call the Mollusk process and validate instruction. Okay. After this, we can run the test. So we can actually do something else, but let's try to do it this way. So we should actually get the result some way so it doesn't complain. I'm gonna do it this way, and then mollusk.process and validate instruction. Which one is it? I think it's this one. No, we don't want chain. This is in case you want to chain multiple instructions one after the other, but we don't want this. You could do that. I usually like to isolate tests. I could just do after this prepare what we need for test withdraw, and then chain this with chain the deposit with withdraw. But I prefer to isolate my test. So in this case, I'm gonna do process and validate instruction. We passed our instructions. We already defined it here. Okay, and then we need to pass our accounts, and this is our transaction accounts. And now the last step is we need to pass our checks. So Mollusk allows you to do a few checks. I prefer to do something like, let me see. You can do something like this. Let's see if this is the right way. So we pass a reference to, let's see if I can remember, what was it? Check. It is the method check. And then we just call it not compute units. It is check again, if I'm not mistaken. Let me see. Success or failure? Yeah, success. That's it. Now, what we could do is, if because Mollusk allow you to do, like, you could pass an account and check the Lamperts when it is initialized or when it is like what is expected at the end. We can try to go to our Mollusk GitHub so I can show you guys. Mollusk, and let me show you guys very quickly. Oh, so slow. Okay. Here, they on one of their examples, they actually show how they do this here. So you could create a vec of checks, and they first check if it is a success, and then we could do something like this: account, and then you pass the account, reference the account you're passing, and then the amount of lamperts you're expecting. So in our case, would be our vault should expect the transfer amount, and our user should have our base lamperts less our transfer amount. Okay, we could do something like that, but what we're gonna do is actually just check the success of it. You don't need to do anything else. Okay, cannot find value instructions in this scope because it's called instruction. Let's call it instructions then. Perfect. Let's test this. But before testing that, let's try to go back and check everything we've done. So this was a mistake. So we first generated all our pub keys you're gonna need for every account we have on our instruction. I put this on top because it's gonna be reused. So we create our instance of Mollusk. We got our PDA states, PDA accounts, pub keys actually, and bumps. We got our system program ID and account. And then we got, we made user accounts for all of them. We made accounts for all of them, for the user, for the state, for the vault. And then we did our accounts meta, so we can use this in to build our instruction. We made our data to inject in our instruction, and so we built our instruction with the instruction new with bytes, where you pass the program ID, you pass the data in the instructions vec and the accounts vec of account metas. And then to process this instruction, we need to provide a vec of accounts, which has the pub key and the account that the pub key is in reference to. And then we call Mollusk process and validate instruction to be able to process this. Okay. Now let us test this. So cargo test. Let's see if it says everything right or if I made a mistake. Yes, looks like I made a mistake. What is it? Failure custom. Message. Program account. Oh, I made a mistake because this is system account. Cool. And did I made any mistake? I don't know. Any other mistake? Let's try to run this again. Two pass. Oh yeah, of course, two pass because this is still here, but it's empty, so it's going to pass automatically. So yes, this was a success. This instruction has passed. So now how we're gonna, so you're gonna see that this is gonna be the same for the next instruction. There's not much changes. So let's do it quite quickly. Let's do a lot of copy and see what changes do we need to do. So I can guide you through this quicker so we can go to the next example. All right. Test withdraw. Now let's change. We're gonna need a Mollusk instance. We're still gonna need our PDA and our vault and our system program. Now the difference is here on our state account, we're gonna actually need to have it initialize, and for that you're gonna have to give them the lamperts. So, and for that we're gonna use mollusk sysvars .rent .minimum balance, and for this we're gonna use let's see, vault state is what it's called, init space. Perfect. And because anchor user discriminator, this is all you're gonna do. And for our space, you're gonna do the same, but our the owner is no longer the system program. is going to be our program. Cool. Now we have our, regarding our Vault account, believe that it is the same account, but it needs to be, this is going to need to be mutable. Our Vault account will have Lamperts now. Okay. And it is still owned by our system program because it is a system account. So now we're going to do our account metas, which remain the same. Cool. But actually before that, we need to inject data to our vault state, so to our state account. That's why it was mute. So let's do that now. So inject data. To inject data, we just first we need to get that data. So let's call initial state, which gonna be a vault state, which has let's go check here a state. A vault bump and state bump. It has a vault bump and a state bump, which is exactly the names we defined just a little bit up. And now we're gonna do let's see, we're gonna have to do something different because this is anchor. So let's call make a let mute state data, and this is gonna be the state account dot data as mutable slice. Okay, so this is giving us a writable account. Did it write a writable account? Yes. And this, now we can use this to pass the data, inject the data, serialized by anchor lang. So we're going to do anchor lang account, no, not deserialize, account serialize, and then we're going to try to serialize it, and we're going to pass our initial state, and then the writer we just created is going to be our mutable reference for a state data. Okay. So our data is now going to be injected to the state account. Perfect. And now let's see, our instructions are okay. Our account metas are the same. But I think there is a difference. Let me see. Our PDA should be a signer, right? Because in our withdraw, we have assigner seeds. Okay. Let's go back. Okay, so for our data, we don't need this. And it's going to be an empty struct, because this is going to be our withdraw. And that's it. The rest is the same. Okay, so it was very easy to change. Mollusk instance, we got our keys and we made our accounts. The difference is, in this case, our PDA state account was already initialized, so we had to give it the minimum balance and the space. Then we had to inject that data to our state account, so we created a state, and then we did created a writable account, and then we injected that there. And then now let me see, then we passed all our accounts, we did our account metas, and we pass our accounts. And so now we just process and validate that. Cool. And we're gonna check if this is right or wrong. Let's see. Okay, this might take a little bit. No. Yeah, yay! They both passed. Perfect. Cool. So this is how you do it. Now, I was going to show you. I was going to write how to make this in a different program, but this video is getting longer than I expected. So let me show you, let me see if I can show you. I think I have this test done somewhere. So let me see if I can actually copy the test so I can show you guys what could be done. Okay. Not this one. Just bear with me. I'm almost there. Okay, cool. Why do I want to show you this example? Let me get these mods. Okay. Why do I want to show you this example? This example is an escrow. We have our make that has a signer, the token mints, which is A and B. We have our maker ATA. We have our escrow, our vault, which is an ATA for this escrow, and then our token program, associated token program, a system program. And these two are the reason why I want to show you how to test this with Mollusk. And then here all we're doing is initiating our state, and then we're transferring the token we expect to our vault. And here in the state we're defining the amount that we need to receive of token in exchange for the one we're depositing. Okay, in our exchange we just take the same accounts, taker, maker, but this is system account, not a signer. We take the same mint. We take the taker ATA for mint A, and this mint B. This is the maker ATA B, and this is the escrow, the vault, and the other accounts. What we're doing here is we first do a CPI to transfer the B directly to from taker to maker. Then we send from the vault, which is the A, the mint A, to the taker, because the maker is providing A tokens to get B tokens, and taker is providing B tokens to get A tokens. And finally, they just close the accounts. Okay, so what is different in this test? The difference is you're going to need the binary. So on Mollusk, you can inject the binaries of these programs. They don't have this extra programs built in. So for the SPL, you're gonna have to dump your the programs you want to inject to Mollusk. In this case, you would do something like, first you check if it is on Solana mainnet, and then you do Solana program dump, and then your program key. And then you would just do the name SPL token or whatever name you want .so, and this will generate the binary for you, and then so that you can load this. And this is what we're doing here. When we do the test make, we just create an instance of that of Mollusk, and then we are injecting. And for this, Mollusk need to be mutable because you're basically mutating that, changing that. So, and you just do Mollusk add program, the program ID, we just got that from SPL token packages, and then you add the where the file is, just like we did here, and then the loader. And for the loader, you use Mollusk SVM program loader keys loader, and this the version depends on your anchor version. You can go for v4, no wrong in there. And after that, you're gonna have this available for you. You're gonna be able to get the token ID for your token program, and then your loader will get the token account, in this case associated account, and that's it. That's the main thing. But also you're gonna have to inject data. So the rest, I'm just getting our PDAs as the same, and because maker ATA and vault pub key, they are ATAs. You're gonna have to use the get associated token address, where you provide the pub key of the owner and then the token mint address. That's exactly what I did here. Then you create your accounts. Okay, that's all we did here was injecting Mollusk with the programs we need and obtaining those IDs and accounts for those programs. Then here we're obtaining all the pub keys we need, the ones that are missing. And here we're making our accounts. And when we create our accounts, because this is a token account, for example, for a MintX account, we need to provide a minimum balance. And we obtain that, and the space is obtained from SPL token state mint length. And this is an SPL token state. And for the ADAs, you just use SPL token as well, but you pass account, not mint. Okay? And after that, you'd still need to inject some data on it. For the mint accounts, you need to use a Solana SDK program pack to inject this information. In this case is a mint, which you're going to give the mint authority, and you're going to hit the supply, the decimals if it is initialized, and if there is any freeze authority. And to add this to your account, is just to mintx account.datasmute slice. That's it. And you do that for all token accounts you have, and for all your ADAs. And this is for mint A, and this for mint B. We call it X and Y here, but it's basically the same, just name change. And then here we defining our maker ADA X or A in our case. And this, we're just giving the amount of tokens they have and who is the owner and which is the mint use reference to. And you do the same. And for the vault, in this case, you don't need to, because the vault is initiated in the instruction. But you will need to do that on your exchange or take instruction. And finally, we have our data. Here, exactly like before, we just ask your instructions, make, and then you pass, because here is seeds receive and deposit, because it's what it's expecting here on LibIRS. As you can see, seed received and deposit from our program. And that's it. Let me see if there's any more changes so I can summarize all of this. No, that's it. Okay, so let's summarize what we learned today. So Mollusk is very fast, as you can see, running all these tests. And all you need to do is set up your accounts. The first thing you do is get your Mollusk instance and get all your pub keys, right? And then if you have programs or additional programs, so for this system program, you can get it directly from Mollusk. But if you have additional programs, you're going to have to dump the binary and load them to Mollusk. Then you can actually get the pub keys and get the accounts. Then you get the remaining accounts. No, the remaining pub keys, sorry. So Mollusk instance, load programs, get the remaining pub keys, get your accounts, make sure that the accounts that are initialized, make sure they have space and lamperts and minimum balance. After that, you're gonna need to inject data if it is needed. So for the token accounts, you need to do that, and we use a Solana SDK program pack to do that. And after that, you just see if there is any data. It's going to be passed into your instruction. In this case, make has 3 arguments. And finally, you get your account metas for all your accounts. Make sure this is in the same order from your instructions. You pass all of that to your instruction new with bytes so you can get a new instruction. And finally, you get your instructions accounts vec so you can pass it to process and validate with your instruction and the checks you want. As you can see, once you understand the structure, it's actually very used to use this tool. And Mollusk is very useful for you to test what happens at runtime very easily without getting bloated with all the accounts and banks and all of that. This is very easy to get what's going on with your program. This is my first go-to, and then after that I just test with the client. But when I'm building up my program, after every instruction I create, I just check with Mollusk to make sure it's correct. I hope you enjoyed this. I definitely did. It took longer than I expected. I hope I didn't bother you with this. But if you like this, please press like, subscribe to Turbine channel. Expect more episodes, and if you have any tool or anything you want us to do, please let us know. And if you have any questions, please also drop a comment. We'll try to address it. Thank you so much, and see you in the next episode. See you.